Hello everyone, welcome back to GoLinuxCloud. A while ago, I had published a detailed step-by-step guide on how to install Kubernetes on Ubuntu 24.10, as you can see on the screen. Now, many of my viewers have asked me to do a practical walkthrough of all the steps done as part of this article. So I have decided to create a video wherein I will show you and demonstrate all the steps which were executed as part of this article and which will help us set up a multi-node Kubernetes cluster. At the time of creating this video, Ubuntu 24.10 had reached the end of its support. So I will be using Ubuntu 25.04, which will work almost identically to 24.10. We will be building a two-node Kubernetes cluster, wherein the first node will act as a control plane node, which we will be referring as master, and the second one will be acting as worker node that will actually run our workloads. Throughout the video, I will explain not just the commands, but also the reason behind executing those commands, so that even if you are new to Kubernetes, you should be able to understand every step clearly. Before we jump to the execution part, let's get started with my lab environment. For this particular article, I had used a different set of VMs, while for working on the video, I have created the VMs with slightly different configurations. So in the current case, I have two VMs with me over here, which are created using Oracle VirtualBox. You can go through the system configuration here, which I have used for these VMs. The important distinction is in the network part. In the article also I had two adapters, but I was using the second adapter as host-only network, while in this particular case I will be using NAT network for all the internal communication. I will not be going too much into details of the reason behind choosing this interface and how these network configurations are different among each other, but I will be leaving some links in the description section which you can go through if you are interested to learn more about the different types of networks which are available in Oracle VirtualBox, and if you wish to learn more about them. For the time being, let's just assume we have these two networks. Although if you wish to create your own NAT network, then you have to come back here and select this particular section, and you can just create a new NAT network, define a particular IPv4 range, what you want to use, enable DHCP, and that's all. After that, you should be able to use a new NAT network, which will be used for all the internal communications. I have already connected to my VMs. As you can see, this is the worker node and this is the master node. Let me show you my OS version. I'll be using 25.04. Before we actually start with the setup of Kubernetes cluster, there are some mandatory prerequisites which must be done to make sure the cluster is functioning properly. One of those prerequisites is disabling the swap memory. Kubernetes depends on accurate memory reporting from the operating system. And if swap is enabled, Linux might move processes out of RAM into the swap space, which will confuse the kubelet about how much memory is actually available. That's why we have to make sure that the swap is disabled. We can use the free command to check the available memory, which also shows us the swap memory. As you can see, by default, the swap is enabled. So let us disable it. This has to be executed using sudo. After execution, we can verify that the swap is successfully disabled. We must also disable the same inside etcfs tab so that this does not get enabled automatically after the VM restart. Just disable this entry. We have to repeat the same on the worker node as well. Let's verify the same. So the swap is disabled. Next is the firewall. Now, firewall is an important part, but since this is a lab setup, I don't want to enable any firewalls in my environment. But in your case, if you prefer to enable firewalls, I have given the list of all the ports which must be enabled on the master and the worker nodes. So you can choose to add these port numbers in your firewall rules. But for me, I will just disable it for the time being on both the nodes. Done. Now, Kubernetes relies heavily on the Linux networking stack. So we have to make sure certain modules and parameters are enabled, which will allow Kubernetes to route the traffic properly between the pods and the nodes. The first module which we are interested is termed as overlay, while the second module of interest is BR net filter, which we also term it as bridge network filter. Both these modules must be enabled on the system where we are trying to establish the Kubernetes cluster, including the master node as well as the worker node. The overlay module will allow one file system to be mounted over the another. Basically, that is what Containerd uses to manage container file systems more efficiently. Without the overlay module, your containers wouldn't be able to share image layers or store writable layers correctly. The second one is used when containers communicate across nodes, and that they will do using the virtual network bridges. By enabling this module, we allow the Linux to inspect and filter packets that travel across these bridges, which is essential for enforcing Kubernetes network policies and for CNI plugins such as Calico, which we intend to use in this particular demo. So let's enable these modules. I am executing these commands from my article, so you can just collect them there. I will be creating a file inside this particular directory so that next time the system boots up, it will automatically load these modules. Let me create the same on the worker node as well. Now at this stage, we have only created the file, but we also need to load these modules manually because we are not planning to restart our system right now. So we can use mode pro to load them. Once they are loaded, we can verify if they are loaded properly or not using ls mode. As you can see, both the modules are properly loaded. Let's do the same on the master node. Let's verify if they are loaded. So the modules are properly loaded in our case. Next, we have to enable certain sysctl parameters to make sure the networking works perfectly. We will be creating a file inside the sysctl.d with some network sysctl configs. This is to make sure when the system reboots next time, these are automatically loaded into the system. Let us do the same on the worker node as well. Now let me explain you what this means exactly. This tells the Linux kernel to pass bridged network traffic through the IP tables firewall rules. In other words, packets going between the pods will now be visible to the IP tables, which will allow Kubernetes network policies to function properly. If this is not done, then the Kubernetes network policy will not work. The only difference between these two params is that this param will apply the rule for IPv4 traffic, while this will apply the same for IPv6 traffic. The third one is used to enable the packet forwarding. It allows the system to route traffic from one network interface to another. Kubernetes depends on this to let pods in different nodes to talk to each other. Now at this stage, we have just created the file. We have not applied these settings. To be able to apply these settings, we have to execute this. Let's run the same on master node. This will basically reload all the configurations available inside the etc sysctl.d where we have placed our file. Now that we are done with all the prerequisites, we will start with the first thing, that is installing Containerd or runtime. Kubernetes doesn't run containers by itself. The kubelet talks to a runtime through a Container Runtime interface or CRI. The most recommended runtime is Containerd, which is a lightweight daemon maintained by the CNCF. We will install the same using apt command. This is required to be installed on both master as well as the worker node. The Containerd is successfully installed. Next, we have to generate and edit the Containerd config. I will be using the commands from my article. This needs to be executed on both master as well as worker node. Let's restart the Containerd and enable it to make sure it gets started automatically. Let's do the same on the master node as well. That's it. To verify if containerd is working or not, we can just check the version. Next, we have to install the required clients, that is the kubelet, kubeadm, and kubectl. The earlier repositories which were used to access and install these clients are not available anymore, and if you are facing error as visible on the screen, then it would mean that you are still using the legacy apt repositories, which is deprecated and not supported anymore. So we will be using the new path to install these particular clients. Let's follow the steps as given in the article. These steps has to be executed on both master as well as worker node. That's it. Next, we can install the packages. While it is getting installed, let's repeat the same on the worker node. It may take some time to install the packages. The next command is quite crucial. Using this command, we are basically holding the packages that prevents automatic upgrades that might mismatch versions across the nodes. So now after this, the automatic upgrades will not touch these packages to perform any kind of updates. We'll do the same on the worker node as well. To check the version, we can execute this. And to check the version of the kubectl, we can execute this. So for us, we'll be using 1.33 version of the Kubernetes client. Next step is to initialize the Kubernetes cluster. This step has to be done on the master node only. For this, we need the IP address of our master node. As mentioned earlier, we have two interfaces. The first one is used to connect to the internet, and the second one is something which we intend to use for internal communication. So for this particular step, we will be using this IP. Next, we have to define the pod network CIDR, which varies based on the CNI you intend to use. In our case, we are planning to use Calico, so for that we have to use this particular CIDR. During the initialization stage, kubeadm sets up all the control plane components under the Kubernetes manifests. Once it completes, it would display you a kubeadm join command. You will need to copy that and store it somewhere safe because we will be needing that command to join all the available worker nodes. Now, even if you miss it, there are ways to refetch it or regenerate it, but to avoid all those troubleshooting steps, it is better that you keep copy of that command somewhere safe in a notepad. As you can see, the initialization of the cluster is complete. Here we can see the kubeadm join command. Let us copy it and store it in the notepad safely, which we will use to run on our worker node later. Next, we have to configure the kubectl for our user. These steps needs to be executed on the master node. That's it. Now your master node is ready. We can verify the same. Now, as you can see, the node status is still showing me not ready. This is because we have not installed any CNI at this stage. Kubernetes doesn't create the network itself. Instead, it uses something called a CNI plugin to handle pod-to-pod communication, DNS resolution, and network policies. So you can think of it like CNI is equal to the network cables and switches between your Kubernetes pods. There are multiple CNI options available which you can find on the official Kubernetes page, such as Calico, Flannel, Weave, etc. For our demo, we will be using the Calico CNI, which is a production grade CNI and very easy to set up. We will be using 3.29.0, but you are free to replace this with any available version of the Calico. As you can see, all the required files have been applied to activate the CNI. Now let's re-verify the status of our node. After the installation of the CNI plugin, the status of the node has changed to ready. Next, we can go ahead and join our worker nodes to the master node. At this stage, we would need the join command, which we had copied earlier. Let's execute that command from the worker node. Let's re-verify the available nodes what we have. As you can see now, I have a new worker node added to my Kubernetes cluster. It is possible that in your case, it may take some time for this worker node to come to a ready state. And if you're not getting to know why there is a delay, you can always check the general CTL logs, which will give you a live update of what is happening basically with the kubelet service. But in most cases, it should come back to ready state automatically. It is possible that if you are using Firewall, then one of the required ports are blocked, which might be causing problem in establishing a secure communication between the master and the worker node. So to debug, you can also try disabling the Firewall for some time and then re-enabling it. Now at this stage, our Kubernetes cluster is up and running. If you're interested, I have also captured some of the troubleshooting steps as part of the article. Feel free to go through them. You can also reach out to me in the comment section if you are facing any other issues or if you have any other questions which you want clarification for. Thank you for watching. See you again in the next video. Thank you.